Hello guys, welcome back to my channel. Hope you are doing well. Today I am here with some of the most frequently asked question from the chapter 8, that is quadrilateral. Okay, now let's see. So that the diagonal of a rhombus are perpendicular to each other. Okay, we need to prove that diagonal of the rhombus are perpendicular to each other. Okay, now let's see. Given rhombus ABCD, okay, to prove AC is perpendicular on BD. Okay, this AC is perpendicular on BD. Fine. Proof. We know that ABCD is a rhombus. Fine. And we get AB equals to BC, BC equals to CD, and CD equals to DA. Fine. Now let's take in triangle AOB and triangle COB. Okay, so OA equals to OC, OA equals to OC. Okay, this is a diagonal. Fine. And to take AOB and COB. Okay, these two triangle. Okay, we need to deal with these two triangle. So we get OA equals to OC. Okay, this is an diagonal. Okay, and OB equals to OB. This is an common. Fine, for the both triangle. And AB equals to CB. Okay, AB equals to CB. The side of the rhombus are equal. Fine. So therefore triangle AOB is congruent to triangle COB. Okay, so angle AOB equals to angle COB by CPCD. Okay, now we know that AC is a line. Fine, this is a line. Okay, so angle AOB plus angle COB equals to 180 degree. Okay, this is a linear pair. Fine. So angle AOB plus angle AOB, okay, angle AOB, okay, is 180 degree. Fine. From equation 1. Fine, this is an equation 1. Okay, and we can add this. Okay, so we get twice of AOB. Okay, that is 180 degree, and AOB is 90 degree. Fine, so we found that angle AOB, this, okay, this is a 90 degree. Fine. From equation 1, okay, angle COB equals to angle AOB. Fine. So we get from equation 1, okay, that COB is equals to angle AOB. Fine. So we get angle COB is equals to 90 degree. Fine. So we get DOC equals to angle AOB is equals to 90 degree, and angle AOD is equals to angle BOC is equals to 90 degree. Okay, these two are the vertically opposite angle. Okay, this and this. Okay, this angle is vertically opposite to this angle and this angle is vertically opposite to this angle. Fine. So angle AOB equals to angle BOC equals to angle COD equals to angle AOD is equals to 90 degree. Fine. So AC perpendicular on BD. Finally, therefore we get the AC perpendicular to BC. Now let's recap. So that the diagonal of a rhombus are perpendicular to each other, we need to prove that the diagonal of the rhombus are perpendicular to each other. Okay, fine. So given we have rhombus ABCD, okay, and we need to prove AC is perpendicular on the BD. Okay, proof, we know that ABCD is a rhombus. Okay, the all sides of the rhombus are equal, so AB equals to BC, BC equals to DC, DC equals to DA. Fine. So we have taken this triangle AOB and BOC. Okay, these two triangle. So we found this is a common. Fine. And AO equals to OC. This is the diagonal, okay, of a rhombus. Fine. And AB equals to BC. Okay. So we get triangle AOB is congruent to triangle COB. Fine. By the CPCT, we make this angle AOB equals to COB. Okay. We also know that AC is a line. AC is a line. Okay. AC is a line. So AO angle AOB plus angle BOC or COB. Okay. We get 180 degree. That is a linear pair. Fine. We get from equation 1 that AOB equals to COB. So we replace COB by AOB. Okay. So we get the twice of AOB, that is 180 degree, and we get angle AOB is equals to 90 degree. Okay. From equation 1, okay, this is an equation 1. We get that angle AOB equals to angle COB. Okay. So we get that COB is equals to 90 degree. Fine. DOC equals to angle AOB. DOC equals to angle AOB. This angle and this angle are vertically opposite angle, and this and these are vertically opposite angle. Fine. So angle AOB equals to BOC equals to COD equals to AOD. Okay. All these angles are 90 degree. Fine. All these angles are 90 degree. So we get AC is perpendicular on BC. Fine. Now let's see the next question. Okay. ABCD is a parallelogram in which P and Q are a midpoint. Okay. ABCD is a parallelogram. P and Q are the midpoint. Okay. Of side AB and CD. Okay. If AQ intersect at S, okay, and BQ intersect at R, fine, we need to show that AP CQ is a parallelogram. Okay, we need to prove this area. Okay, this area is a parallelogram. Fine. Now let's see. Given ABCD is a parallelogram with PQR midpoint. Fine. We have of midpoint of AB and CD. Fine. We have already given that ABCD is a parallelogram and P and Q are the midpoint of AB and CD. Fine. To prove APCQ is a parallelogram. Fine. Proof AB is parallel to DC. Okay, we know that the opposite side of the parallelogram are parallel and equal. Okay, AB is parallel to CD. Okay, so we get AP is parallel to QC. Okay, with the help of AB is parallel to CD, so we get AP is parallel to CQ. Okay, or QC. AB equals to CD. Okay, half of AB equals to half of CD. Okay, that is AP equals to QC. Okay, this AP equals to QC. Okay, P is the midpoint of AB and Q is the midpoint of CD. Okay, so we get AP parallel to QC and APCQ is a parallelogram. Fine. Therefore, APCQ is a parallelogram. Fine. Okay, this is our first step to this is our first question. Okay, let's see the second part of the question. Okay, now we need to prove that DPBQ is a parallelogram. DPBQ is a parallelogram. In first part we prove that APCQ is a parallelogram. In second part we need to prove that PBQD is a parallelogram. Okay, or DPBQ is a parallelogram. Okay, in a similar way we need to prove this also. Okay, we already know that AB is parallel to DC. Okay, PB is parallel to DQ. AB is parallel to DC. Okay, so we get BP is parallel to QD. Fine. AB equals to CD. Okay, parallel side of the parallelogram. Okay, and or the side of the parallelogram. AB is a half of and half of CD. Okay, so we get the PB is equals to QD. Fine. P is the midpoint, okay, of AB and Q is the midpoint of DC or CD. Okay, fine. So PB is parallel to DQ or QD. Okay, and PB equal to DQ. Fine. So therefore DPBQ is a parallelogram. Fine. In the first part we proved that APCQ is a parallelogram, and second part we proved that PBQD is a parallelogram. Okay, fine. Now let's see the third part of this question. Okay, now let's see. P PSQR is a parallelogram. Okay, this is a diagram. Okay, ABCD. Okay, this is a parallelogram and this is a midpoint of this. Okay, and in first part we proved that APCQ is a parallelogram, and in second part we proved that DPBQ is a parallelogram. Okay, in third part we need to prove that PSQR is a parallelogram. Okay, inside this, okay, we need to prove this parallelogram. Okay, now let's see. We prove that DPBQ, okay, this is a parallelogram. Fine. From the part 2, okay, from the part 2, and so we get that DP is parallel to QB. Okay, the opposite side of parallelogram are parallel. Fine. And SP is parallel to QR. Okay, this is an equation 1. Fine. And in part 1 we proved that APCQ is a parallelogram. Fine. So AQ parallel to PC. Okay, opposite side of the parallelogram are parallel, and SQ is parallel to PR. Okay, this is an equation 2. Okay, from equation 2 and 1, okay, we find that SP is parallel to QR. Okay, and SQ parallel to PR. Fine. Therefore, PSQR is a parallelogram. Fine. SP is parallel to QR. Okay, SP is parallel to QR. Okay, SQ, where is it? SQ is parallel to PR. Okay, fine. Now let's recap all the 3 parts. Okay, in this ABCD is a parallelogram in which we have already given the midpoint, that is a P and Q. Okay, on AB and CD. Okay, fine. And AQ is intersection at S and BQ is intersection CP at R. Okay, we need to prove that in first part that APCQ is a parallelogram. Fine. We have already given all these things, that ABCD is a parallelogram and P and Q are the midpoint on the AB and the CD. Fine. In the first step we need to prove that APCQ, okay, is a parallelogram. So we have already know that opposite side of parallelogram are parallel and equal. Okay, so AB is parallel to DC, okay, or CD. Fine. So we get AP is parallel to QC. Okay, why? Okay, why we get AP is parallel to QC? Because half of AB and half of CD, we get AP is equals to CQ. So P is the midpoint of AB and Q is the midpoint of CD. Fine. So we get AP is parallel to QC. Okay, and AP is equals to, AP is parallel to QC and AP equals to QC. Okay, and APCQ is a parallelogram. Okay, fine. Therefore, APCQ is a parallelogram. Prove that DPBQ, okay, in third part DPBQ, this, okay, in the same way which have been proved in part 1, we need to prove exactly the same. Okay, we know that opposite side of parallelogram are parallel and equal. Okay, so AB is parallel to DC, so we get the PB parallel to DQ. Okay, so half of AB and half of CD, we get the PB is equals to QD, and PB is parallel to QD. Okay, and P and Q is the midpoint of AB and CD. Fine. So at last we get DP BQ is a parallelogram. Okay, now let's see the third part. In third part, we need to prove that PSQR is a parallelogram. Okay, we already proved that DPBQ in a part 2. Okay, so we get DP parallel to BQ and SP parallel to QR. Okay, in part 1 we proved that APCQ is a parallelogram. Okay, so we find AQ parallel to PC and SQ is parallel to PR. Fine. From equation 1 and 2, these two equation, okay, we find that SP parallel to QR and SQ is parallel to PR. SP, fine, this parallel to this and this parallel to this. Fine. So we at last we get PSQR is a parallelogram. Okay, fine.